Hi, we would like to present the project on which we will be working for the last year for the Photo8 company in a group of Mateusz Biesiadowski, Edward Sucharda, and me, Jakub Walendowski. And our supervisor from the university was Dr. Piotr Bieliński. Okay, so what was the topic of our project? The goal of our project was to generate an image of a person in a different cloth, especially the elegant cloth. And the assumptions of our projects were pretty precise, as the input image with a person for which we should do this transfer was preprocessed by other Photo8 tools to prepare this image to official documents restrictions, as our generated photos will be used in passports or ID cards. Okay, so images will be 512 by 512 pixels, and also the person on the input photo will be from the chest up, from the mid chest up, on the white background, and this person will be looking forward. Yeah. Okay, and our output photo should look natural for the human eye. Yeah. So how we were trying to solve this task, we decided to look on 3 different solutions, and one of them was to use GANs. Actually, we used GPN, and the results doesn't look so good, so we abandoned this this way. Then, and in parallel, actually, we look for the text-to-image solutions, as products as DALL-E 2 are pretty popular nowadays. And this time, the results were good. They were really good, but there were another problem, because the API delivered by OpenAI was not free, and Photo8 company asked us to look for another solution. So we looked for the stable diffusion models, and this time again the results was not so good, as the texture of the new generated cloth looks unnatural. Finally, we looked for the simplest solutions from all of them, and it's in painting, and it's based on cutting out the old cloth, putting the new cloth, and then trying to fill the void between the neck and the face of a person with some in-painting model like Llama. Okay, so maybe go to the details of this in-painting. As you can imagine, in this project we have to do some segmentation of photo, and we choose the Face Toolbox Keras model, which was ready to use, and it was okay for us. Okay, some more details. To properly translate and scale face to the new cloth, we have to analyze the characteristic points of the cloths and face, and also we have to analyze these points to generate a mask for the in-painting model. And how we do it? We use this segmentation, actually the segmentation on the neck, then do some convex hull on this, and then choose extreme points as the points to generate this mask and prepare the translations.
Yeah, so this is how we chose the human characteristic points, and the clove characteristic points are pretty straightforward because we actually give the user the clove that he can choose. So we actually can decide ourselves, even memorize the pixel coordinates that we want to be characteristic for this matching. And before matching, we had to remove the clove and try to remove as much body unnecessary as much as we can, because and it was not such an easy task, because in this segmentation that we used, there was only classes like neck or skin, and by skin it was only the skin of the face. So that's why sometimes we get little problems, because the chest, when it was visible because the clothing was, let's say, small, then we had sometimes also parts of chest classified as a neck. But we did some removing what was unnecessary, and then we tried to do the affine transformation. So we had those characteristic points on the border between face and neck and top collar on the cloth, and we just needed to adjust. We knew that the cloth and the person is in the proper orientation, so we didn't want to use any rotation. So we just adjusted the scale by adjusting on the x-axis the clothing, and the translation was so that one of these points has to be a little bit lower than the face neck border, and the other one cannot cover the face. So depending on which collar point was higher, and depending which face point was higher, then it could differ a little bit. The next step was removing blobs and neck errors, because sometimes, as you can see here, the neck went off the collar but crossing it. So that's of course not a good result. So what we did was we did a small white edge on the cloth, and then just remove all the small objects that were on the image that were not on the that were not white, and the results are pretty good. And okay, yeah. Another problem was that after just pasting the cloth, the image looked a little bit artificial. So we did some tricks like shadow generation, and how we did it, we just changed the RGB scale to HSV, and gradually were lowering the value and adding a little blur, and the results, in my opinion, are pretty good. The last step of our project was the inpainting. So, of course, the shapes of the clothes before and after transformation are not exactly the same. So we just, at the few slides ago, you've seen that the cloth was with a small green part between inside the collar. So this is the initial inpainting mask, And when inside this initial in-painting mask there are white blobs, then we decide to in-paint those parts, and this is the final results of the transfer. As you can see, the results are sometimes good, sometimes bad. It's a lot of depends on the person and on the image. So first condition that is very important is that the neck has to be very good visible, because for example, if we have a situation like this, that the girl is, half of her neck is covered by her hair, then the results are bad. The same situation is about people with really long beard. Then there are some problems. Of course, we have sometimes some problems with segmentation when the part of the t-shirt stays and we do not in-paint this part, or some problems where we have a hoodie that covers her, and we could do in-painting here, but the results would be so bad that it doesn't really make any sense, and we know that it's not okay, but in-painting wouldn't make it much better.